welcome to another edition of James and Chris Science Videos, where today we're going to be looking at energy transfer chains, how to draw them, how to work out what's inside them, and then look at that with a couple of examples, including one of my favourite pieces of equipment in the science lab, my steam engine, which I get very excited about. So let's start off with reminding ourselves of the different types and forms of energy that we can get. So in the previous lesson we talked about storing energies. We looked at GPE, chemical and elastic as being those energies where we can store energy in a form. The doing energies were energies that move around, and you can see them with different particles moving. We talked about that again in the previous video. And they were kinetic energy, that's a physical solid object moving. Light, sound, heat and electrical. So we're going to keep referring back to those because those are our forms of energy. And energy can't exist in any other forms. There are some others that you do A-level GCSE, but for the moment, in terms of Key Stage 3 and Common Entrance, then you're looking at those energies only. So here's a form of energy. Here's a candle that's burning. So let's look at the energies inside that candle. We're going to start off with the energy contained within the fuel. And so candle wax is a hydrocarbon, so that would be a fuel. And we talked previously about fuels being a form of chemical energy. So the initial energy in my device here would be chemical energy. Now I've set fire to that, and that's releasing the energy in different forms. And so I've got my chemical energy being transferred into light energy. And I've just put there, that purple arrow that goes across is how we represent is transferred to. So it's how we show that the chemical energy has moved across. Now, the more astute of you will notice that it's not just light energy that a candle produces. Also, it produces heat energy. And so we can show when there's two energies being produced, we can show that with a plus sign. So here I've got light energy plus heat energy. And I've got to decide for my device which is the most useful of those energies. So for a candle, generally we use that for lighting. So you put the light energy as being the useful energy first, and the heat energy comes second. And that would generally be considered a wasted form of energy. So let's look at a more complicated example. Here is a steam engine, a model steam engine. Now I've got one of those in the lab. So what I'm going to do is I'm going to go to the lab, we'll talk through this, and we'll show all of the different energy transfers that happen when we set my steam engine going. So we'll head to the lab now. I'll see you in a second. Unfortunately, the sound on this did not come out clearly enough, so I'm just going to talk over whilst I do the experiment. Unfortunately, the microphone had been scratching. So here we go. We're in the lab. This is my steam engine, of which I get very excited about. In fact, it was the first object I bought as head of science. So if we turn it round, here we've got the cylinder. Inside here there is water. You can see that sloshing around slightly. There is the water there. Now, in order to get this to work, you put the water in there, and you've got a valve on the top here. So that valve will be a safety measure that will stop the steam from the pressure getting too high. Any steam that is able there will push through, push those two pistons, and enable the wheel to turn. So let's light the fuel. And the fuel, here we go, is paraffin blocks, which is a hydrocarbon. There you go. And those hydrocarbons, because it's a fuel, would be a form of chemical energy. Inside there, the energy is locked up within the hydrogen and carbon atoms, and so we've got that hydrocarbon being hydrogen and carbon joined together. So if we light it, which we'll do here, we should be able to release some of that energy in various different forms. Now, the blocks are notoriously difficult to light. The reason they're difficult to light is that in order to get an object to light, you first of all have to vaporize it. You have to heat it to a point where it melts and then start to evaporate. And once it's evaporated, you can then set fire to that. So you can see one block's gone. We'll have to get another match out now to get the second one going. There we go. And if you put the match onto there, again it vaporizes and eventually you can ignite it. So let's just wait for that to happen. Right, there we go. So we have, you can see, two energies are being transferred from the chemical, we are transferring it into heat and light. Those are the two that are being formed. So what I want to do now is I want to put that under the cylinder, and inside there, that's going to heat up the water. It's going to boil it. So the particles, when we start to boil a liquid, the particles move faster, they spread out, and so they'll try and take more space, and that will create a higher pressure. Okay, we're about ready. You can hear it hissing, and that here is the valve where the pressure inside is building up, and you can see that pressure there is allowing the steam to escape so that it doesn't explode. Now, if I keep my finger on it like this and then put a pair of tongs to kind of compress it, then that's going to kind of build up the pressure, which is going to be good for what I'm going to do in a second. So far we have turned chemical energy into heat and light. I'm going to use the heat energy now to make the particles move. And we had a word for that physical moving of objects and particles, and that's kinetic energy. So I'm going to use that pressure to force the steam out through here. So let's force it out. That's built up enough now. And we're going to get that to turn here. There we go. And you can see the kinetic energy there. It's quite impressive, isn't it? So that is turning chemical to light and heat. The heat gets turned into kinetic, which makes that spin. And the last thing I'm going to do is I'm going to tap this chemical and I'm going to put it into there. And we're going to turn it back on again. There we go. And now we've got chemical energy turning into heat and light, which turns into kinetic energy. Let's see if I get that going faster. There we go. So my kinetic energy is now turning a generator, which is turning it into electricity. And electricity is being turned here back into light and heat. And it's the basic model of how we generate electricity in this country using the old-fashioned fossil fuel method. So we heat up water, we turn the water into steam. I'm just going to put this into a seat so that it cools down. It's quite satisfying. Woohoo! There we go. Nice little paraffin one now. Yeah, that's nice, isn't it? Yeah. So, chemical, heat and light, kinetic, into electricity, into light. And this is the model of how a power station works. Brilliant. I hope you can see how excited I got. But let's talk quickly about some of the energy transfers that have happened inside this model. I'm going to start off with, again, like before, our starting energy is going to be the fuel. And so the fuel contains energy in the form of chemical energy. We set fire to that, so it burns. And unlike the candle, this time the heat energy is the useful energy, and the light energy is the energy that it isn't going to be useful. So my first chemical change is chemical energy into heat plus light. I explained that the heat energy then makes the water particles move. It turns it into steam, it builds up the pressure, and then we can get that pressure to move the air particles through the tube and to turn the turbine. Now we call that a physical movement of particles, so we call that kinetic energy. That kinetic energy then turned a generator, and that generator was the silver object around the side, and that generates electrical energy. So we turn that kinetic into electrical energy. Finally, that electrical energy is turned back into light and heat energy via the light bulb. I should say each of these points where we get a change we call a device. And so I could talk about the generator being a device, the light bulb being a device, the pistons being a device, the boiler being a device, and so on. So a device is an object that changes energy from one form to another. So let's look at a really easy example. This time I'm just going to take something up high and I'm going to drop it. So we're going to go back to the lab and we'll explain that from there. Okay, I've got one more chemical transfer to show you, and that is this. It's very simple. I'm going to stand carefully on top of a stool, like so. I'm going to take my block and I'm going to put it as high as I can above the table, and then I'm going to drop it. There you go, made the dog jump. So, the energy transfer from that, we went up high, so that's gravitational potential. I let go, which turned it to kinetic, which moved. It hit the floor, which made a sound, and so I turned it into sound energy. Another simple energy transfer chain. Right, simple, wasn't it? Startled the dog, which is always good fun, but there we go. GPE is how we started. We take the ball, I think it was a pen in this case, up high, and then when I let go of the pen, it contains that gravitational potential energy. That gravitational potential energy is going to turn into kinetic energy, and as it falls. And so it loses gravitational potential and it gains kinetic energy as it goes down. It gets faster, but it's going lower. Eventually it hit the table and it made a sound, but also when you hit things they heat up ever so slightly. So the temperature of the table would have raised by a small amount. So I've got those two energies there. Neither are particularly useful, so I've put sound energy as being the one that is most obvious and it produces the most. So the majority of the energy would turn into that sound energy. So it's your turn now. What I would like you to do is to go around your house and pick 5 devices. And then for your device, take a picture of it and put your energy transfer chain. Now technically, each of the energy transfer chains should start with a storing energy. But if you're using an electrical device that plugs into a plug, we can start with electrical energy, because if we trace it back, that electricity will be made by a power station of some kind, and we have no way of knowing which type of power station, whether it was solar power, wind power, oil-fired, gas-fired, nuclear, we don't know. So we can start our energy transfer chain at the point that we do know, which is with the electrical socket. So if it's a plug-in device, start with electrical energy as your first. If it's a battery device, then your battery contains chemicals, and that should be a clue for how to start that energy transfer chain. So come back on for the summary once you've got your 5 different devices with energy transfer chains. The summary then, let's look at this. The energy, first of all, by the law of conservation, energy cannot be destroyed or created. It can only be transferred from one form into another. So the law of energy states that that is what happens for energy. It's never created, destroyed, it's just changed. We can show those transformations using the energy transfer diagrams. That's what we've been looking at. Chemical energy into electrical energy into, and so on. And so we show within that diagram the transformations with an arrow, and we can show if there's 2 produced at the same time, that with a plus. Thank you very much for watching. Hope to see you again soon. Bye bye.